Hello, thank you for clicking on the link to my YouTube video on straight line graphs. During this session, which I recorded on my iPad and I took on my home PC using the visualizer, I go through a recap on linear sequences or arithmetic sequences and then link that to straight line graphs. So graphs of the form y equals 2x, y equals 3x, x equals 4 example. I hope you find it useful. Here we go. So what you might notice is the sequence is going up by 3 each time. So it's linked to the 3 times table. So it is linked to 3n. Now those numbers are not the 3 times table, because the 3 times table starts on the number 3. It goes 3, 6, 9, 12, 15 and so on. So these numbers are 4 less than the 3 times table. So it is 3n minus 4. So we've got an ascending arithmetic sequence that goes up in 3. So the term-to-term rule is add 3. So it's linked to the 3 times table. And the numbers are 4 less than the 3 times table. The person who suggested to me 3n minus 1, that's a really good shout, because the numbers 2, 5, 8, 11 are 1 less than the 3 times table, but you've got to look at the starting number, and minus 1 is 4 less than 3. Okay, now I've given you a backwards problem just below. I've said write down the first 5 terms of the sequence with the position to term rule for n minus 2. So if we start with n, there are 2 operations that we are doing to n. If we draw a function machine, and the number that comes out is 4 times the number, take away 2. So our first operation for n means n times 4, and then taking away 2, we write that in take away 2. So for the first term, n is 1. 1 times 4 is 4, take away 2 is 2. The second term in the sequence, 2 times 4 is 8, take away 2 is 6. So I can start writing these in a table. So again, if we have the position and the term, our first term we're going to write in first. I might smudge that a little bit actually. So when n was 1, our term was 2. When n was 2, our term was 6. When n is 3, 3 times 4 is 12, take away 2 is 10. So the third term is 10. So our sequence goes 2, 6, 10. So 4 times 4 is 16, take away 2 is 14. Okay, and then I'm going to take a little shortcut here. We can see the numbers are going up by 4 each time. So the next one must be 18. Okay, now I'm going to give you the same question in a very slightly different way. So you'll see I've put some axes on the screen as well. And this time, instead of n and the nth term, we are going to look at straight line graphs. And instead of 4n take away 2, I'm going to put y equals 4x take away 2. So whatever x is, we times it by 4 and we take away 2. So this is going to look almost the same as what we've done before, except instead of n going in, x is going in, because when we draw graphs and do coordinates, we have an x coordinate and a y coordinate. We are still timesing by 4 and then taking away 2. Okay, and out comes y. As well as doing this for 1, 2 and 3, I'm going to actually start with x equals 0. So when x equals 0, 0 times 4 is 0, take away 2 is minus 2, so y equals minus 2. And I'm going to plot that on my graph. So I'm going to go along to 0 and down to minus 2. The rest of the numbers you are going to recognise. When x equals 1, 1 times 4 is 4, take away 2 is 2. That's the same as the first term when we looked at sequences. So the coordinates are 1, 2. Go along to 1 and up to 2. When x equals 2, 2 times 2 is 8, take away 2 is 6. So when x is 2 here, y is 6. So along to 2 and up to 6. Okay, and we can continue to put those in a table if we like, which is the way I would always recommend doing this. So down here, I'm going to draw a table, and instead of position and term, I'm going to put x and y. So when x was 0, this is the one different thing to sequences. I do like to use zeros. I could actually choose any values for x, but I like using 0, 1 and 2 because they're nice and easy. So when x is 0, y was minus 2. When x was 1, y was equal to 2. When x was 2, y was equal to 6. That was this point. And then when x is 3, 3 times 4 is 12, take away 2 is 10. So we have this graph, and 3, 10 is also on that straight line. Y equals negative 2x plus 1. So here, if we got x going in, minus 2x means we're timesing by minus 2. So if this was a sequence, it would be descending. And then we are adding 1 to get y. So if x was equal to 0, 0 times minus 2 is 0, plus 1 is 1. So on this new graph, let's just label the old graph so I know which one it is. So that is y equals 4x minus 2. On this new graph, the point 0, 1 is on the graph. Let's do this in a different colour. So let's do this one in pink. So 0, 1 is on my graph. Then, when x is equal to 1, 1 times minus 2 is minus 2, plus 1 is minus 1. So we have the coordinate 1, minus 1. When x is equal to 2, 2 times minus 2 is minus 4, plus 1 is minus 3, or negative 3. So it would go 2 minus 3. And finally, if we do x equals 3, 3 times minus 2 is minus 6, plus 1 is minus 5. So we have got the point 3 minus 5. Now when we draw those, we should get a straight line. It's going down because it would have been a descending sequence if it was a sequence. it's going down by 2 each time. So it's got a gradient of -2. And that line has the equation y equals -2x plus 1. Now, all of this working out here is very good. If you can do it by putting the numbers straight into a table, though, that is more than enough working out. So again, choose the nice easy numbers 0, 1, 2 and 3, and we got y as being 1, -1, -3, -5. Now hopefully by doing this you see some similarities with sequences, because this sequence is going up, so it's going down by 2 each time. Okay, and if you were doing this as a sequence, you wouldn't have a 0 term. The sequence would have started -1, -3, -5, and it would have been the nth term -2n plus 1. Graphs of linear functions work, or arithmetic functions work, in exactly the same way. So I'm now going to put a fresh piece of paper in front of the camera with the axes on, and we're going to look at some unique lines that often catch people out. Okay, so the line y equals x. This one is quite an easy one, because whatever x is equal to, 0, 1, 2, 3, y is always equal to the same thing. So if y equals x, x equals 0, y equals 0, x equals 1, y equals 1, and so on. So the graph y equals x will just go through 0, 0, 1, 1, 2, 2, 3, 3, and that would be the diagonal line going upwards. So that is the line y equals x. Here's another one. Let's choose a different colour. Let's go with pink. If we had y equals -x, whatever x was equal to, 0, 1, 2, 3, y is equal to whatever x is, but negative. So 0, -1, -2, -3. So the points would be 0, 0, 1, -1, 2, -2, 3, -3. So we would get a diagonal line with a gradient of -1, a diagonal line that goes down by 1 for every 1 we go across. Now, sometimes you might be given something like this. Y equals, can you see the difference between purple and pink? You can just about, can't you? Y equals 3. You probably wouldn't do a table for this one, but it doesn't matter what x is equal to. Y is always equal to 3. So if x is 0, y is 3. If x is 1, y is 3. X is 2, y is still always equal to 3. And that would give us, if we got the point 0, 3, 1, 3, 2, 3, 3, 3. When it's y equals a number, it's going to be a horizontal line that crosses the y-axis at that number. So that is the graph of y equals 3. Okay, let's do one more before we sum things up. Let's go to green. This time, x equals -4. So when we do the table for this one, x and y, well, this table's even more pointless because we can't take x equals 1, because x is never equal to 1 or 0, always equal to -4. Whatever y is equal to, x is always equal to -4. So y could be 0, 1, 2, x would always be equal to -4. I'm just looking for a slightly better green actually. So this x coordinate here is always -4. So we got the coordinates -4, 0, -4, 1, -4, 2, and so on. So -4, 0 is there, -4, 1, -4, 2, -4, 3, and so on. So when it's x equals a number, we've got a vertical line that crosses the x-axis at that number. So that is the graph of x equals -4. Okay. Now, if you have logged in on the FCC YouTube channel or clicked the link, thank you very much. I hope you found that useful, and I will hopefully see you again on watching my YouTube videos soon. Thank you very much for clicking on the link. Bye-bye.